Hello everyone. Today we are going to discuss uh, about Van de Graaff generators. So basically, what we are going to study today is how Van de Graaff generators work. First, we will study their working principle, and in the next video, I'll study their practical usage and how the machine actually looks like. So, Van de Graaff generator is basically, if I'm oversimplifying a bit, then it's basically a shell or a sphere inside another shell. And then you provide it with ample amounts of charges right here. All right. And then you close the circuit between the both of them. So both of these are metal, by the way, just in case you haven't realized from the surface charges. Both of these are going to be metals, and this is a circuit which was open, and then we close it, right? Now, as soon as we close it, what we notice is that all the charges, they surface to the outside of it, right? Now, the question arises, why does that happen? Why is it so that all the charges come up to the outer surface from the inner surface? There must be a reason, right? So, the way I would like to explain it to you is by the method of potential. So, we are going to compare the potentials of these two shells. And the way we can do that is first we need to understand that charges charges move towards lesser potential. Okay, charges move towards lesser potential. This is fundamentally part of nature. So, in order to achieve stability, the potential energy needs to be minimized. Okay, this reminds me that I'm also going to publish a video about dipole moments and their stability in equilibrium. So it will also involve the same concept that PE needs to be minimum for stable equilibrium, and when it is maximum, you are in a state of unstable equilibrium. Unstable equilibrium is the state just before disorder. So, disorder arises from order when there is unstable equilibrium. We are going to study that in the next videos. Now, what I would like to cover is that we know at this point of time, this has higher potential and this has lower potential. But we need to generalize this being higher potential and this being lower potential when they have partial charges of Q. So Q can be divided into Q1 and Q2. And let's give it the charge Q1 and let's give it the charge Q2. All right. So at the surface of this shell, the potential can be given by the expression kq1 by small r plus kq2 by larger r, right? This is the potential at its surface. So we are using the concept that a shell uh, has potential equal to the potential at the shell, even inside the shell, right? That is why this is the expression for the potential subtended on it from the outer surface. Now, when we compare it with, when we analyze and compare it with this, now this is the expression for the outer surface, right? This is the expression for the outer surface. In this case, what happens is both of them have the same radii for basically the expression of potential. Now, if we were to compare them, if we were to figure out the difference, let's call it V1, let's call it V2. So V2 minus V1 would equal KQ1 1 by R minus 1 by R. This is what it would equal because these cancel out, and this is what we are left with. This is what we have to work with. Now, this is a smaller number because this is inner radius. If the divisor is a smaller number, then this will be a larger number, right? And if the divisor is a larger number, then this will be a smaller number. So it is basically a positive value for any charge distribution with Q1 and Q2, where Q1 is on the inner shell and Q2 is on the outer shell, right? This is what's happening. Now we basically are able to figure out that all the charge provided to this shell will indefinitely move towards the outer shell. That is what is going to happen, right? Now this is it for this video, and in the next video I'll discuss a PYQ related to Van de Graaff generators, and then we'll discuss why is it so that on a complex body the surface distribution of charges on a complex metallic body is indirectly proportional to the local radius of curvature. So what happens is, if we have a body that looks like this, the charges are more likely to be present here than here. We'll study why that happens in the next video. It is related to this, so I would suggest that you watch this first. Thank you.